Okay, right. So in this question here, question 4, we are given this expression here. If you can see, it is actually a hyperbola. And the first question says that we must find the coordinate of the y-intercept of f. So we're having f of x being equal to 2 over x plus 1 minus 3. The y-intercept when x is equal to 0. So f of x is equal to 2 divided by 0 plus 1 minus 3, which is equals to 2 divided by 1 is 2 minus 3 is equals to minus 1. So this is your value of y. So in coordinate form, you're going to write 0 and minus 1. And then here in 4.1.2, we are asked to calculate the coordinates of the x-intercept of f. So the x-intercept when y is equal to 0, so in the equation of f of x is equal to 2 over x plus 1 minus 3. So where there's f of x, you put 0 is equal to 2 over x plus 1 minus 3. Take the minus 3 to the other side. You have 3 is equal to 2 over x plus 1. Then you cross multiply. So you're going to have 3 into x plus 1 is equal to 2. Divide by 3 both sides. Or you can multiply inside. It's up to you. So I'm just going to divide. You have x plus 1 is equal to 2 over 3. Then you transpose the 1 to the other side. You have x equals to 2 over 3 minus 1. So therefore, our x is going to be equals to minus 1 over 3. So your coordinate form is minus 1 over 3 and 0. And then we are asked to sketch. So in 4.1.3, we are asked to sketch the graph and show clearly all the asymptotes and x-intercepts. So I'm just going to write the graph just here at the bottom. So we're having our intercepts. So we have our x-intercepts, which is minus 1 over 3. We have our y-intercept, which is 0 and minus 1. So it's important. And our asymptotes. So we have our equation is this one here, our asymptotes. Our vertical asymptote is equals to minus 1. Our horizontal asymptote is equals to minus 3. So when you draw your graph, your minus 1 because it's vertical. So it's vertical asymptote, which is x equals to minus 1, and your horizontal asymptote, which is so let me do this. So you're having your Cartesian plane. This is your y, this is your x, and this is your vertical asymptote. Your horizontal asymptote is given as y is equals to minus 3. And you've already found your x-intercept. Your x-intercept is this one, minus 1 over 3 and 0. So minus 1 over 3, it's minus 0.333. So it's just here before negative 1. You're going to indicate that it's actually a minus 1 over 3 and 0. And then another coordinate, it's 0 and minus 1, which is here, which is 0 and minus 1. So you're just going to join your points together, and this would be your graph, and another one here. So how do you know that this is in this plane? How do you know that we should draw it here and not the other sides like here and here? So we see by the value of a. So if you see our equation, which is this one here, let me write it properly. So it's f of x is equal to 2 over x plus 1 minus 3. So in this equation here, our a value, which is this 2 here, our a is equal to 2. So our a is greater than 0. So when a is greater than 0, so let me indicate here, our hyperbola is going to be in the first and third quadrant. So when a is greater than 0, meaning it's positive, our hyperbola is going to be in the first and third quadrant. So these quadrants are actually your asymptotes. It's not just your Cartesian plane. You look at the asymptotes. Cool. So when a is less than 0, in between your asymptotes, your hyperbola will be in the second and fourth quadrants. So that's how we drew our sketch here. So in 4.1.4, we are told that one of the axes has an axis of symmetry, or one of the axes of symmetry rather, of f is decreasing. So we must determine the equation of the axis of symmetry that is decreasing. So we have two axes of symmetry. So if you draw your asymptotes, let's say these are the asymptotes for a graph of a hyperbola that is greater than 0, meaning this graph will lie in the first quadrant of the asymptotes and the third quadrant of the asymptotes. So your axes of symmetry, they are always passing through your asymptotes, always. So this is the positive axis of symmetry. Positive, meaning the gradient is equals to 1. Sorry. So this is the negative axis of symmetry. It's decreasing. So meaning the gradient here, it's equals to -1. So this is the gradient of the axis of symmetry, this one here, because it's decreasing. And then another axis of symmetry passes through here, which the gradient for this one is increasing, so it's +1. Right? So if you were to write the equations of this specific parabola, you're going to say y is equals to mx plus c, right? Which it would depend where your c is, but what you need to note is your gradient for the positive one is going to be x plus c. So you're gonna use your asymptotes to find c. So you're gonna use your asymptotes as a point, right? So let's say, for example, your asymptote is 0 and 0. So you're gonna substitute 0 here and 0 here, so which means your value of c is 0, right? So your asymptotes, you always use them for substituting as a point, because these are your asymptotes. They're passing through these two lines here. Cool. So now let me solve this problem here, which says that we must now find the equation of the negative axis of symmetry, -1. So the -1, or the decreasing one, because something that's decreasing, it's just showing a negative sign. So it's m equals to -1. We know the gradient. So the equation is y is equals to mx plus c, but you know it's y is equals to -x plus c. So the point that we're going to use to substitute to find c is the point of the asymptotes, as I said, asymptotes. So you're going to substitute the asymptotes. We know that in our equation we have the vertical asymptotes, as you can see there. Just going to go back. This is the vertical asymptote, which is equals to x equals to -1. So this is -1. Horizontal asymptote, it's equals to -3. So y is equals to -3. So you write it here, it's -3. So you're going to substitute it in this equation. So this is y, this is x. So where there's y, you put -3 equals to negative. Where there's x, you put -1 plus c. So this is going to be 1 and this is going to be -3. Transpose the 1 the other side, it's going to be -3 minus 1 is equals to c. Therefore, c is equals to -4. So the equation of the negative decreasing axis of symmetry, it's y is equals to the -x minus 4. So this is the equation. So now in this problem here in 4.2, we are given a function of this equation, which is sketched here below, and we are given that point C is the x-intercept of t, and A is just the point at t. So this is A, and this is your C. And then we are required to find the coordinates of C. So how do you find the coordinates of C? You have T of x is equals to log of base A x. So we want to find 4.2.1, right? So what is your T? This is C, right? So if you were to assume or write the coordinates of C, we don't know the value of x, but we know the value of y, which is 0. So meaning here at T of x, we're going to write 0 is equals to log the base. We don't know the base, so you're just going to write A and then x. Then to write properly, you're going to say x is equals to a to the power of 0. Anything to the power of 0 is 1. So meaning our x value is 1. So x is equals to 1. So therefore, your C in this case is going to be 1 and 0. That's why it's 1 mark. So it's going to be 1 and 0. So this is your answer for 4.2.1. Now 4.2.2, you're asked to write down the range of the graph of T. So the range, looking at this, so when you talk of range, because there's a domain and there's a range. The range, we focus on the y values of the graph. We interpret how the y values are operating, are moving. So if you look at this graph here that is given, the y values come from a certain point up there. We don't know from which point. And they go to, so it's how you interpret it. Because this is an exponential graph, you can interpret it from the bottom to the top. Why? Because the bottom has negative y values. Remember that here it's negative y, here it's positive y. So this graph comes from a negative infinity of y, and then it goes to a positive infinity of y. It's going up and it's going down to values we don't know. So to find the range of y, we're going to say y is the element of negative infinity to positive infinity. So this is your range. And then now we are asked to find the value of a. So we know our T of x, the given equation, it's log base a x, right? And we want to find this a value here. So to find this a value, you need to substitute a value here and a value here at x. So what are you going to use? You're going to use a point. So in this case, you're going to use the point of a, which is 5 and minus 1. We're given this point here, which is 5 and minus 1. So we're going to substitute it in this equation to find our value of a. So which means where there's T of x, you put minus 1 is equals to log the base a x, you put 5. So to write it properly, you have minus 1 is equals to log base a 5. So a to the power minus 1 is equals to 5. Right? And we want to find a is equals to not a to the power minus 1. So you can multiply by 1 over minus 1, or you can simply just write it in this form. You have 1 minus to the power minus 1 is equals to 5, right? Write it as 1 over a is equals to 5. Cross multiply, you have 1 is equals to 5a. Divide by 5 both sides, you have a is equals to 1 over 5. So this is your a value. So now we are looking at 4.2.4. It says that the graph of h is equals to T of x is transformed by a reflection of T about the line y is equals to x. So the original graph is transformed. So we are required to write down the equation of h in the form y is equals to. So this is what's happening here. We go back to our graph. Let me erase everything here. So the given graph looks like this, right? And we are told that we want to find the equation of h, which is equal to t of x. But it's the reflection of this about the line y is equals to x. So the line is equals to y is equals to x is this one. This is the line of y is equals to x, where the y value is equals to the x value. Now we want to find an equation of h. So meaning it is going to be the inverse of t, because a graph that is reflected about this line of y is equals to x is an inverse, right? So we know that t of x is equals to log of base ax, of which we found, but a was equals to 1 over 5. We just calculated it. So meaning our t of x is equals to log base 1 over 5 x. So this is our equation of t of x, which if you write it properly, you're going to say y is equals to log base 1 over 5 x. But because we want to find the inverse of this, the inverse is the exponential equation. So what you do, you just write this in exponential form, right? So meaning the 1 over 5, which is this base here, to the power of y is equals to x. But remember, when you do the inverse, we swap. Where there's x, you put y. Where there's y, you put x. So meaning here, 1 over 5 to the power x is equals to y. So y is equals to 1 over 5 to the power x. So this is our equation of h, which is a reflection of t. Then now, so we are done with this, So now we want to do 4.2.5. Write down the domain of h. So we know the equation of h. h is equals to y is equals to 1 over 5 to the power x, right? The domain. So when you talk of the domain, we're talking of the x values. We want to interpret the x values. If you look at this graph here, the reflection of this graph will pass through here, basically. So this is the graph of h, right? So the x values come from that direction, the negative infinity, and they go to a positive infinity. The x values, the domain. So to confirm the domain of h, we are simply going to say x is the element from negative infinity to positive infinity. So that's the domain of the function. Now let's go to 4.2.6. Write down the equation of the asymptote of h. So now we want to find the equation of the asymptote. You already have the equation of h, which is y is equals to 1 over 5 to the power x. Normally the asymptotes of an exponential, it's written here, it's plus a certain value, of which this equation doesn't have that. It's just this expression here, meaning your y is equals to 0. Your horizontal asymptote is 0. So that is the solution for this problem here. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.